Again, since we've now covered a lot of the basics from a scientific perspective of how you wind up with the orbit of a planet, its star or stars it orbits, and the various forces of nature that would have an effect upon it structurally, we've more or less got the basics of the planet on a broad scale. There's still a little bit more to cover, but for today, however, we'll be covering things that aren't exactly tangible in quite the same way. Like, for example, how a world may not have an oxygen atmosphere, or where certain resources we take for granted may be missing, or may possess resources we don't have on Terra itself, such as magic, mithril, generic unobtainium, or whatever along those lines. So let's get started then. First off, we've touched on gravity a few times, but not so much directly how it'll affect the creatures on your world for the most part. Remember here, lower gravity tends to mean bigger creatures, and not just taller ones. It also means you'll have creatures which would be heavier, since they can add more mass without it getting in the way so much, and it won't harm their joints when walking about to the same extent. A low-gravity world also affects how digestion works, in that we found that some birds can't digest meals properly without gravity, so you're going to see some variations in how things evolve to cope with such. You'll also note in extremely low-gravity settings, such as our moon, Luna, walking like we do on Terra isn't really that effective of a form of locomotion. At 1/6 standard Terran gravity, traveling on Luna involves bouncing in a sort of makeshift hopping motion. This is basically what you'd see on Mars as well. For a lighter planet, you'd see very different forms of locomotion in use. If you also toss in a more dense atmosphere, like say increasing the oxygen content to 40%, it's pretty much expected that you should see something akin to sky whales as a natural progression of such, since the air would be almost like a soup, and when paired with lower gravity, it's reasonable to see very large, heavy creatures which are aerodynamic and basically swim through the air. Plant life would also tend to grow to excessive heights, and you'd naturally see a very tall forest covering where the top of the forest blocks out virtually all light, meaning things closer to the ground would probably have to find other sources of energy. You may very well see creatures without eyes, such as you get in the deep ocean or in underground cave systems, where it simply costs too many calories to develop eyes that don't do anything. Alternatively, eyes or similar luminescent sensitive patches could very well develop which see into different wavelength ranges, such as the infrared spectrum, being able to see radiant heat instead. Now conversely, in a low oxygen or perhaps a helium-based atmosphere, you'll find that things just aren't very buoyant. The less dense the atmosphere, the bigger and wider you have to make your boat of sorts, even if that boat is an enclosed organic creature. Same thing goes for oceans as well. We're used to oceans of water, but that's not the only form of oceans that exist. On Jupiter, it's a gas planet from top to bottom, but with how the pressure works, it goes from being a gas to a liquid to a solid without any clearly defined, discrete states in between each. It just kind of gets progressively thicker as you go deeper. Now, where this gets really interesting is that the upper clouds of Jupiter are very similar to what we think the early ingredients needed for life to begin with were like here on Terra. meaning you could quite reasonably have life begin on a gas planet with intense gravity, but a very low-density upper atmosphere, and then you'd see different creature types evolving at different densities throughout the clouds. On a more solid planet, heavy gravity doesn't just make creatures smaller in both height and overall size, but it also changes the type of locomotion you're going to see. You won't really see a lot of birds or similar creatures unless you have an exceptionally dense atmosphere to go with it. You won't see bipedal creatures as often since our form of walking is technically controlled falling forwards. And when it's hard to stop falling, since the gravity is so strong, it wouldn't be an ideal way of handling such any longer. Unless you had your bipedal creature evolve on another planet and move to the heavy one. That's why the dwarves in Saorsa are interstellar in nature. They didn't originate upon a high-gravity planet. They moved to one and adapted to its gravity because they wouldn't have developed bipedal motion in the first place otherwise, probably at least. You'd quite likely see creatures that roll in balls as well for traveling downhill. Like, picture a hedgehog where it curls up into a ball, but where the spines are densely packed enough to roll upon them, with eyes all over the body which get combined together, sort of like the compound eye of an insect, compiling information from many directions at once in a sort of 360 spherical view of the world, keeping the eyes near the base of the spines so they never touch the ground kind of dealing. Such a creature would make perfect sense on a high-gravity planet. Now, another thing to keep in mind is that life draws upon the materials that happen to be nearby. If you don't have calcium as common material in your world, you're not going to get calcium-based bones. We use what happens to be handy. If there's no way to get a resource, you don't use that resource. If a resource is abundant, you'll probably figure out a way to put it to use. Which is something that bugs me a great deal when I see fantasy worlds where there's magic everywhere. Tons of just high natural background mana levels, and yet the flora and fauna don't use it. Of course they will. If it's an abundant resource, sooner or later, something will have a minor mutation which allows it to feed upon such, or use it as a defensive measure, a way to hunt prey more effectively. The instant that happens, it'll have a vastly better chance of successfully surviving long enough to breed and pass down that gene. And so you'll find that creatures and plants which can tap into magical resources will do so readily. For another Saorsa example, the dragons present require mithril in their diet because it's part of how they maintain their capacity for flight. That's what their bones are made of instead of calcium. It's lightweight, but excessively durable, making it an ideal building tool for body parts that need to be rigid, but handle high stresses upon such. And what this means is that any resources you have on your planet are going to be incorporated into the living things there. But you're also going to find it alters the landscape as well. Like, over on Titan, Saturn's largest moon, there are oceans of liquid ethane and methane, and it's theorized that the inside of the moon is filled with a highly salty ocean, akin to the Dead Sea here on Terra. These kinds of factors change a lot of properties. It doesn't mean life can't exist in these situations. Like, we're used to needing fresh water to survive. Yet, many fish thrive on saltwater environments, which would kill us quite quickly. if you had an ocean planet with a mermaid population or something similar, you'd have to take into account whether it's a saltwater environment or a freshwater one. Or perhaps whether it's not even using water at all. Just because we happen to be made mostly of water doesn't mean life on other planets will be the same way. It's mostly just a matter of convenience. Water's really common on Terra, so that's what we use because that's what's available. Now, admittedly, water's kind of common just in general in the universe, since it's made out of two really common ingredients, namely hydrogen, which is by far the most common of all, and oxygen, which is still pretty common. And the two naturally form water pretty easily without much effort. In fact, it's often more effort for these two elements to not form into water when they happen to be near each other, because it's a lower energy state. As such, you're probably not going to see a planet without much liquid water, unless it's really hot or really cold, or unless some other factor has played a significant role in the development of the planet. Like, if there's a ring of really massive planets in the solar system which round up all the comets, your inner planet may never get hit by them to have water deposited in the first place. It would still have lots of hydrogen and oxygen anyway, just because they're common elements. Unless, something tampers with such. Like, let's say your oxygen gets infused with mana on a fantasy world and becomes some new element instead. This new element no longer bonds easily with hydrogen, or perhaps its valence electrons don't work the same way anymore, so it only becomes one hydrogen and one mana oxygen. This changes a lot on the properties of how water would work, since you wouldn't have that 120-degree hydrogen pair, which works really well at making water molecules able to line up together in neat, tidy rows. And that's just for altering something which already exists. Your planet may very well have completely new elements which don't exist at all in reality, or which may be much more rare most of the time. Our planet has a relatively high amount of uranium in its crust, for example. At least given how rare uranium should be. But it's typically not that common near the surface. Your world may have a high abundance of radioactive material, or may have all sorts of other properties that most people would have difficulties even dreaming of. The point here is that even before we start laying out things like land masses or oceans or creatures on a planet, it really helps to define all of the unique properties of what's available for materials to work with. These materials will play a major role in not just how the planet itself forms and the kinds of geological features you see, but these are the very building blocks on the flora and fauna which shall rise there. Even if you have a deity who creates life manually on your world, that deity is still going to want to automate most of the processes and use as many of the raw materials which are already available as possible. And so, even in a magical world, or one with many gods and goddesses, you're going to find that what raw materials you put into your world will affect what the world outputs. If you have some very dense material being very common, like gold's super common on your world, then you're probably also going to have a pretty dense planet to go with it, and very high gravity because of exactly that. Sure, the cities of gold look nice and all, but they're probably going to be rather tiny. Not because of a lack of gold, but because the creatures that inhabit the world will probably be very small because of how high the gravity of a planet with a large amount of gold in its mantle would be. Well, that and it's not a very good building material. Again, this is a large part of why we're going through the whole concept of world design in this particular manner. Everything you do at one stage branches out and affects the other stages. If you're informed upon one thing, then that one thing informs you on more things. The whole world practically builds itself, feeding itself information recursively as you go. So, homework time. Yeah, you got off easy for a while there with the forces of nature. Well, I hope you enjoyed your vacation, because now we're back to work. Fortunately, as stated, a lot of this will basically write itself for you, so it's not nearly as difficult as it first looks. The homework itself for this week is to pick at least 3 resources on your world and tweak their quantities significantly. This could be anything from adding new materials which don't exist in reality, to increasing some materials to be more common, such as an increase of oxygen or gold as we discussed, or restricting how common something normally is, like water. This doesn't sound like a lot, but it's going to trigger a cascading effect of subsequent things, which change because of these alterations. The second part of your homework will be to consider what these changes will do to your world. How each change will alter things like the gravity, the buoyancy, and density of the atmosphere. If you think it'll have an effect upon the kinds of physical features you'll see for land masses, oceans, or even the creatures and plants which evolve there. We'll be going into a lot more detail on all of these things later on, especially the whole evolutionary process, so don't worry about getting super ultra fine detail at the moment, but do start to put a little thought into things that'll show up later on down the line, and make choices now that you think will influence things in an interesting way later on. Keep in mind that anything you do here can, and probably will, turn into a plot hook at some point in any book, game, or other form of media you create based upon this world. The world itself is a character in your story, essentially. More than that, it's the stage upon which all other events occur. The more effort you put into setting the stage to be interesting, the more things that you can use to make your story more interesting as well. Even small, subtle changes at this stage in the world's development can make a big difference later on, so give it some careful thought. Anyway, I think we've covered enough here today, so with that, I'm out. I'll see you next time.